Hello and welcome to our physical sciences session. My name is Temba Ngube. Today we are focusing our attention on a certain aspect of matter and materials which has to do with exploring exactly what happens when a form of matter changes from one state to another. So the word state and phase, we shall for now use them interchangeably to refer to one and the same thing. Without any waste of time, let's look at the bigger concept map in as far as how exactly change or phase of matter fits into the broader matter and materials knowledge area. Right. Okay. So we are saying that now we understand that it has a lot to do with a physical change, which has to do with also the properties of matter. But we also want to explore exactly what exactly happens when a phase changes from one form to another in a given type of material or matter. Okay, so the thinking exercise that's going to guide our discussion for today is, have you ever thought about, number one, what exactly happens to a substance when a phase change occurs? So our emphasis in this case is exactly on the change of phase from one to the other amongst the three phases that we know of, which is the solid, the liquid, as well as the gas. And then the second thought that we want to entertain in our discussion is that what is the role of energy, when a change of phase of a substance occurs? So these are the two big ideas that we want to try and use to guide our exploration of understanding exactly what happens when there's a change of phase of matter. Right. Now, when it comes to the terminology, which is the definitions, which is an all or nothing kind of an arrangement. Now, remember, we need to refer to the guidelines in terms of the examination so that we get the accurate or what exactly the examiner needs because different sources will obviously, phrase the same definition maybe in a different way. But beyond that, understanding the key words that must be used in the correct context is also very important. We cannot overemphasize the importance of that. Right. So what are some of the key words for today? We talk about the freezing point, which has to do with the temperature at which a certain phase change occurs. But let's be careful not to confuse between the process, okay? So freezing becomes the process, and then the temperature at which that process occurs or that phase change occurs, it's obviously the freezing point. So these are actually the different temperatures at which phase change occurs. So this has to do with temperatures, okay? It has to do with temperatures at which phase changes occur. So these are various phases that we're talking about. It could be from liquid to gas, or solid to gas. So these are temperatures at which phases change, okay, for a particular substance. So the processes that has to do with the melting point is obviously the melting, okay? Boiling point has to do with the boiling or change of phase from liquid to gas, as well as condensation. So these are the key terms that you need to pay careful attention to, right? Okay, now, what is it that we know already? We know that matter exists in any of the three states, okay? So whatever substance that you pick up or you identify, it can, depending on the condition of temperature, pressure, they would either exist in the form of a solid, a liquid, or a gas. So it entirely depends. But over and above, we are all saying that now. These are the three phases that are important that we need to take note of. So these are obviously the solid, the liquid, and the gas. Okay, now we'll take turn to look at one of them at a time and try to look at the properties of each one of them so that we understand exactly what happens during the transition in terms of the state or the phase. Okay, now let's look at the properties of a solid very quickly. Okay, let's use the simulation just to guide our discussion. Right, here is a simulation that shows the behavior of particles that make up, in this case we've chosen water as an example. what are some of the important things that we can immediately pick up from the simulation is that these particles, are they in a state of motion? Maybe that's the first question that we need to ask ourselves. Yes, indeed, they are in motion. But to what extent do these particles move? They are only vibrating within the fixed position, okay? Now, also, you would also realize that when you carefully analyze that simulation, it shows that much as the particles are vibrating or shaking, they maintain a certain definite shape or volume in terms of space. This is in the backdrop of the fact that we understand that any form of matter has got mass and occupies volume or a space, or it's got volume. So there is a definiteness of shape as well as volume in as far as the solid is concerned. Okay, now the movement of the particles suggests that there are some forces that act between the particles. These forces are relatively stronger. So the term relative suggests that it's by comparison to another phase of matter. Okay, let's go back to our simulation, our presentation, and look at the individual properties of or characteristics of a solid. So the vibration suggests that there is some sort of movement, okay, that the particles are experiencing. And the moment we spoke of movement, we're thinking immediately of the kinetic energy. Do these particles possess kinetic energy? Most definitely. So within fixed position, it means they maintain their position. However, the movement is restricted. Why? Because the forces are very strong. So the word very suggests that in comparison to other forms of matter, these are actually stronger, okay? And then thirdly, we are saying that these particles are closely pegged, okay? Why are these particles closely pegged? Because we attribute that to the strength of the forces that exist between the particles. I think it all comes together in that way. And also, they are generally incompressible. What does it mean when we say solids are incompressible? If you analyze the arrangement of particles that actually make a solid, there are very little spaces in between them because of these strong forces, because they are closely pegged. So it becomes difficult for us to be able to compress a solid so that it changes its shape, or it changes, its size, whichever way you choose to look at it. But because of these smaller forces, which can be attributed to the stronger forces, all solids are incompressible in general. Okay, so they retain their shape, then we'll say they've got a definite shape, right? So all solids have got a definite shape. Okay, it can be regular or irregular. By regular, we mean it could be a block, it could be a prism. These are regular shapes. It can be also irregular, right? Okay. Now, the other property of a solid is that they have specific melting point under standard condition. So we are saying that a given solid material or substance will melt at a certain temperature under different conditions. Okay, that's the long and short of it. Okay, now let's look at the properties of a liquid. Okay, what is it that we know about liquids? But before we do that, let's draw our attention to the simulation and try to look at, for argument's sake, a liquid. Water as an example. You may obviously pick up some of the obvious, properties that, yes, indeed, the particles are in a state of motion. There is some movement, but the movement is much greater compared to those between, the solid particles. And also, there is some evidence that suggests that the forces are comparatively weaker than those of a solid. In terms of shape, you'd realize that there is no definite shape. In this case, the liquid takes the shape of the container. So these are some of the obvious characteristics or properties of a liquid that must come to mind, right? If you can go back to our simulation to actually look at the slides in terms of the summary, it says here that the particles, they slide past each other. Okay, so sliding suggests that there is some movement that the particles are experiencing, but these forces, by comparison, they're actually weaker than those of a solid, right? And also, the forces between the particles are weaker, so that's the comparative term, okay, compared to those in a solid. The spaces exist between these particles. There are some spaces, but these spaces are actually smaller. Pay careful attention to that, okay? They are generally incompressible, and they exert pressure in all directions. So what we would know even from, our obvious knowledge to say that, okay, if you have a liquid, it's very difficult for you to compress the liquid so that it occupies a lesser space. Why? Because the spaces that exist between the particles of any liquid substances are so small such that, the difference in terms of compressing it changing its volume is quite insignificant. So it is too small to notice. As a result, we can safely say that generally most liquids are actually incompressible, right? Okay, and then we also understand that they do not have a definite shape. That's why they take the shape of the container, okay? And they have a specific boiling point and freezing point under specific conditions. So the boiling point has a lot to do with the temperature at which a certain phase change occurs, as well as the freezing point, okay? But this is under standard conditions. We shall discuss what exactly standard conditions are all about, okay? Right, what about gases? Let's use the same simulation, but now draw our attention to a gas, right? Here's a simulation that resembles the behavior of particles of a gas. It's still the same substances, which substance that we're using, water molecules. Now you can immediately tell that the extent of movement of particles is by comparison far greater than those of a liquid as well as a solid, okay? And also the spaces. Can that be a suggestion about something which has to do with the forces that exist between the gas particles? Definitely. So there is a lot of spaces due to weaker forces, and that's why these particles are actually free to move, in a random or haphazard fashion. As a result, a gas tends to fill up any space that's available within the shortest period of time. Why? Because these particles are actually moving very, very fast. Okay, so in short, what are we saying in as far as the gases are concerned? We know that the particles, the movement is random, but this movement has a lot to do with the kinetic energy. All right, we shall talk to kinetic energy a lot, which has to do with the movement of particles, due to their speed. The faster they move, the greater the kinetic energy or the extent of movement. We also realize that the forces are very weak. So very is the comparative term. These forces are weaker compared to liquids as well as solids. There are huge spaces between the particles because of weaker forces, right? And also, these are actually compressible, okay? Now, we are saying that because of spaces that exist between, gas particles, it's easy to compress a gas, so it can occupy a lesser volume. So that is possible, which the same cannot be said about solids as well as liquids, right? Okay, now, and all gases exert pressure in all directions. We shall talk about what exactly a pressure of a gas means, because you immediately realize that, okay, so if we were to model the behavior of particles of a gas, this random movement of particles, filling up, all the spaces available has a lot to do with the pressure that, a gas exerts inside, in a container. So the faster these particles move, the greater the pressure. And it has a lot to do with the energy of movement of these particles. But remember, all this is possible because there are weaker forces that exist between the particles of a gas. As a result, there is a greater extent of movement, and there are a lot of spaces in between these particles, right? And also, we can safely say that they have a specific condensation point under standard condition. Okay, the word condensation is one of the key terms that we referred to earlier on. So condensation it has a lot to do with the phase change from, gas to liquid. So when a gas condenses, it liquefies, it becomes a liquid. Okay, that is a phase change, which is the big idea of today's discussion. But remember, for condensation to occur, there needs to be some cooling of some sort, which takes us to the second question of our discussion to say, what is the role of energy in as far as, phase change is concerned? Okay, so this is the most important part of our our introduction in as far as the phase change and us understanding what exactly happens when there's a change, in a state of matter, and how exactly energy, impacts on the phase change. That said, let's take a short break. We'll join again in the second segment where we take the discussion further. Let's take a short break for now.